Jai Hind students. So in the previous lecture we had discussed about resistance offered by a conductor, isn't it? In this particular lecture, or rather in this session, we'll discuss about the resistance, which is the opposition, hindrance or obstruction offered by a cell or by a battery or by a source towards the flow of current. And that resistance, students, it's known as the internal resistance of a cell. So, in today's session, we will be discussing these terms. We'll discuss about internal resistance. We'll discuss about the factors on which the internal resistance of a cell depends. Then we'll discuss about open circuit and closed circuit. These are two important terms so as to able to understand the terms EMF and TPD, which is the terminal potential difference, which we'll discuss in the next lecture. Right? So, let's start with the internal resistance. And again, before dealing with this particular topic, we need to be familiar with the basic composition of a cell or a battery or a source. Now students, you are aware, simple voltaic cell, Daniell cell, Leclanche cell, dry cell, which we often use in our daily life. These all are the examples of primary cells, which once used can't be recharged. The chemical reactions taking inside these cells are irreversible, isn't it? So all these cells have common construction in the sense that each one of them has got a vessel or a container containing two electrodes. One is known as the anode, the other one is known as the cathode, right? And which are immersed in electrolyte. So that's the basic composition of a cell, right? I'll represent it with a diagram. Cell or a source, it's like this. It's a container, right? These are the two electrodes. One is the anode, the other one is the cathode. These are the two electrodes. One will act as the positive terminal, the other one will act as the negative terminal. That is, this electrode will be at higher potential, this electrode will be at lower potential. So what's the main role of the cell? It is to provide or to maintain a constant potential difference. It is at higher potential, it is at lower potential. So when the two ends of a conductor are connected to these two terminals, then a constant potential difference will be maintained, which will enable the free electrons inside the conductor to drift in a particular direction, and eventually it will constitute electric current, right? So these two electrodes are immersed in an electrolyte. It may be in the solid powdered form or it may be in the liquid form, right? So these are the two electrodes. These are the two electrodes. One is the anode, the other one is the cathode. The process of oxidation takes place at anode, while reduction takes place at cathode, right? This is an electrolyte. This is an electrolyte. It's a liquid through which, when the current is passed, then it dissociates itself into ions, cations and anions. And this is suppose the external circuit. This is suppose the external circuit. This is the key and like this. This is the external resistance. This is suppose the external resistance. And this is key. So if the key is closed, so the cell is maintaining a constant potential difference, so the current will flow from higher potential to lower potential. So outside the cell, the direction of the current is from higher potential to lower potential. Inside, the current is from negative electrode to the positive electrode, like this. So basically, as the current flows, this liquid, which is electrolyte, dissociates itself into ions. Positive ions and negative ions. Positive ions and negative ions. So, as the circuit is closed, what happens is the ions, which are cations and anions, tend to drift in a particular direction, right? Now, these ions are quite large in number, and also they have to move against the backdrop of several other ions and neutral atoms. So during their motion, what happens is the motion of the ions get hindered, or it get obstructed, or rather it get opposed. This opposition, hindrance or obstruction offered by the electrolyte of a cell towards the flow of the current is known as internal resistance. Now students, we will discuss the factors on which the internal resistance of a cell depends, right? So, first is, it depends upon the nature of the electrodes. It depends upon the nature of the electrodes. It also depends upon the nature of the electrolyte. It also depends upon the nature of the electrolyte. It does depend upon the cross-sectional area of the electrodes. The greater the cross-sectional area, the larger the cross-sectional area, the lesser will be the internal resistance offered by the cell. So it depends upon the area of the electrodes. And I am talking about that area of the electrodes which is immersed inside the electrolyte. So, larger the area of the electrode, smaller will be the internal resistance offered by the cell, right? It also depends upon the distance between the two electrodes. The closer the separation between the two electrodes, the lesser will be the internal resistance. The larger the separation between the two electrodes, the more will be the internal resistance offered by the cell. So it does depend upon the distance between the electrodes. And most importantly, it also depends upon the temperature. Here I must mention, with the increase in the temperature, the internal resistance of a cell decreases, and with the decrease in the temperature, the internal resistance of a cell increases. So just do remember that. With the increase in the temperature, the internal resistance of a cell decreases. Right? Do remember this. It's inversely proportional. Right, students? Unlike conductors whose resistance increases with the increase in the temperature, in case of internal resistance of a cell, it tends to increase with the decrease in the temperature, and vice versa. So these are the factors on which the internal resistance of a cell depends. Now how to electronically represent the internal resistance in a circuit? So it can be represented like this. This is a cell. So this is the internal resistance. It's represented by a small letter r. Right? This is the internal resistance. Or it may be represented in this manner as well. This will suggest the internal resistance offered by the cell or the source. So internal resistance will be represented by small letter r. Clear, students? So let me repeat these two concepts. One was the internal resistance. It is the opposition, hindrance or the obstruction offered by the electrolyte of a cell towards the flow of current. That is known as the internal resistance. So what was the theoretical concept? When the current flows through the electrolyte, then it dissociates itself into ions. Those ions have to move against the background of some other ions as well as some neutral atoms. So as they drift in a particular direction, the motion is hindered because they suffer collision with each other and also with the neutral atoms of the electrolyte. So since the motion gets hindered or obstructed, that opposition offered by the electrolyte of a cell to the flow of current is known as internal resistance. Right? And what are the factors on which internal resistance depends? It depends upon temperature. With the increase in the temperature, the internal resistance of a cell decreases and vice versa. It depends upon the nature of the electrodes. It depends upon the nature of the electrolyte. It depends upon the separation between the two electrodes. Smaller the separation, lesser will be the internal resistance offered by the cell. It does depend also upon the area of the electrode which is immersed inside the electrolyte. Larger the area, lesser will be the internal resistance offered. Also, we have noticed, students, for a freshly prepared cell, I repeat, for a freshly prepared cell, the internal resistance is found to be negligible, or it's very, very small. But with the passage of time, after its prolonged use, the internal resistance of the cell keeps on increasing with the passage of time. And eventually, ultimately, it increases to such an extent that the cell has to be discarded, or it has to be thrown away. Right? So, for a freshly prepared cell, the internal resistance is very, very low. So, these are the concepts involved in the internal resistance of a cell and the factors on which the internal resistance depends. Now, let's concentrate on the last two topics, open circuit and closed circuit. Open circuit, students. Let's consider the case of an open circuit. This is a source. As I have told you, a source is a cell or combination of cells which maintains a constant potential difference across the ends of a conductor across which that source is connected. So it enables the charge, which are the free electrons inside a conductor, to drift in a particular direction, and it is only then it constitutes electric current, right? So that's cell or a source or a battery for you. This is a key and this is a circuit, suppose. This is an external resistor. This is an external resistance. External resistance we represent it by capital letter R. And suppose this source is offering an internal resistance smaller. So it may be represented like this. This is the internal resistance offered by this source, right? Now, open circuit means when no current is derived from this source. That is when the current flowing in the circuit is zero. No current is flowing through the circuit. Or the key is open. So there is discontinuity in the path of the current. So as a result, no current flows through the circuit. So that is known as an open circuit. Now, if no current flows through the circuit, then no current flows through inside the cell as well. So internal resistance will have no role to play in an open circuit. Clear, students? I repeat, a circuit is said to be open when no current is derived from the source. That is, the current flowing through the circuit is zero. That is, the switch is open. So, due to the discontinuity or due to the breakage in the circuit, no net current flows through the circuit. And as a result, the internal resistance of the cell do not play any role in an open circuit. This internal resistance of the cell do not come into action in an open circuit, right? But on the other hand, in the case of a closed circuit, like this is a closed circuit, right? Now what happens is when the key is closed, now it will complete the circuit. Circuit, you are aware, it's a continuous closed path of the current, that is the circuit. So the circuit gets completed. So now some finite value of current will flow, and the direction of the conventional current is always from higher potential to lower potential. So definitely the circuit gets completed. So the current will flow through the electrolyte of the cell as well. And when the current flows through the electrolyte of the cell, then obviously the positive and the negative ions, while they drift in a particular direction against the background of some other ions and other neutral atoms, the motion will get hindered. So the electrolyte of the cell or the source will offer some resistance to this movement of current. So here comes the role of internal resistance. So basically what I mean to say is that in the case of a closed circuit, when some finite current is drawn from the source, then the internal resistance does come into play. That is, in this case, in order to overcome this internal resistance offered by the source, a potential drop of IR takes place. This is the potential drop. A potential drop of IR takes place in order to overcome the internal resistance offered by the source. Right? So that's regarding open circuit and closed circuit. Open circuit means when no current is drawn from the source. Closed circuit means when some finite value of current is drawn from the source. So in the open circuit, internal resistance do not play any role. In the closed circuit, internal resistance does come into play. It does come into play. And as a result of which, there is a finite potential drop across the internal resistance of the source. And what is that potential drop? It is I into small r. So this is the potential drop. So what happens is, out of the total energy of the source, this energy get dissipated in overcoming this internal resistance. Understood, students? So what I mean to say is that in case of an open circuit, if you connect a voltmeter over here, suppose this is an open circuit. This is the case of an open circuit, and let us consider this to be the case of closed circuit. Suppose a voltmeter, it's offering internal resistance R. Suppose a voltmeter is connected over here. A voltmeter, I have told you, it's a device which is used to measure the potential difference across the two terminals. It's a voltmeter. This is a voltmeter, right? So here, in case the circuit is open, no current is flowing through the circuit, then it is the case of open circuit. In such a case, internal resistance will not have any role to play. It will not come into existence because no net current flows through the cell or the source. So in this case, when a voltmeter is connected across the terminals of the source, then it will show maximum reading. It will show maximum. In this case, the voltmeter will show maximum reading. While on the other hand, the same circuit, consider this, when the key is closed. Now some finite value of current will flow through it. So the current will flow through the electrolyte of the cell as well. So now the internal resistance will come into action. And as I told you earlier, in order to overcome this internal resistance, a potential drop of IR will take place. So now if the same voltmeter is connected over here, it will show lesser reading. By what amount it will show less reading? By amount equal to the potential drop across the internal resistance of the cell. So suppose it is V1 and let us consider this to be V2. So definitely V2 would be less than V1. V1 is maximum. And by what amount it will be less than that of V1? It will be less than V1 by an amount equal to the potential drop across the internal resistance of the source. Clear, students? Again I repeat, please concentrate. It's a very, very important concept. In an open circuit, no current is drawn from the cell. No current is flowing through inside the cell. So internal resistance will not have any role to play. In such a case, if a voltmeter is connected across the two terminals of the source, it will show maximum reading. Let us consider it to be V1. While in this case, when the same circuit is closed, some finite current will flow through the circuit, some current will flow through the electrolyte, so internal resistance will be offered by the cell. So therefore, current I is flowing through the electrolyte of the cell. Therefore, a potential drop of IR will take place across the internal resistor. So now, the voltmeter in this case will show a reading less than that of the previous reading by an amount equal to the potential drop across the internal resistance of the cell. This potential difference, students, this potential difference, which is across the terminals of a cell in a closed circuit, when some current is drawn from it, it is known as TPD. It is known as terminal potential difference. While on the other hand, this potential difference, which is across the terminals of a source in an open circuit, when no current is drawn from it, it is known as the EMF. It is known as electromotive force. It's a misnomer. It does not represent any sort of force. It is actually maximum potential difference. It is work done per unit charge in moving the charge from one point to another point so as to complete the circuit. Right? So we'll discuss about TPD and EMF in detail in the next lecture. So here in this particular session, what we have discussed is internal resistance of a cell, the basic structure of a cell, isn't it? Then we have discussed the factors on which the internal resistance of a cell depends. And then we have also discussed regarding open circuit and closed circuit. And I have given a brief intro about TPD and EMF. These are the two very important topics, students. TPD stands for terminal potential difference. EMF stands for electromotive force. Both are potential difference, right? So it is a misnomer, it does not represent any sort of force. But these are the topics which we will discuss in detail in the next lecture. So till then, revise whatever is being taught to you and stay fit and stay healthy. Thank you.